Okay, in this particular video we will do a practice of the dimensions of the four fundamental subspaces. Okay, now you already know we have discussed this in detail earlier. Let me quickly give you a recall. The first fundamental subspace is the column space of A, and the dimension of the column space of A is the column rank. But for a matrix we know that the column rank and row rank are same, so basically we can simply call this the rank of A. Simply the dimension of the row space of A, okay, row space of A, which is simply the column space of A transpose, obviously because the columns of A, rows of A are columns of A transpose. This is also the row rank of the matrix, which is simply the rank of A. The dimension of the null space of A is the nullity of A, and nullity you already know is the number of free variables in the reduced row echelon form. So that is what the dimension of the null space of A is. And the dimension of null space of A transpose is the total number of rows. This is the number of rows because A is a m by n matrix. Okay, A is an m by n matrix, so assume this number of rows minus the rank. Okay, rank of rows, which is rank of A. That is what this idea is. Now then again you have done a theorem in matrices, that the rank nullity theorem, that the rank plus nullity is equal to columns. Rank plus nullity is equal to columns, which is in the case n. So if my rank of the matrix is R, let's call this as R, and the total number of columns in the matrix is n, the nullity simply will be n minus R. That's what the nullity is. So if you get the rank, you know the columns, you can simply subtract and get the nullity. Vice versa, you know the nullity and columns, you can get the rank. In a similar way, if you know the number of rows and you know the rank, you can get the dimension of the null space of A transpose, this as well. Okay. So this is basically the idea of the dimensions of the four fundamental subspaces. Let's take up an example to get the dimensions. Okay. So I'm not giving you any matrix. I'm just telling you that a 4 cross 3 matrix has rank 1. A 4 cross 3 matrix has rank 1. You find the dimensions of all the four fundamental null spaces, subspaces. So if rank is 1, I already know that the column space of A, the dimension of the column space of A, the dimension of the column space of A transpose, which is row space of A, is already 1. Okay. Then I need to find out the dimension of the null space of A, which is simply the nullity. I'll use the formula, the rank plus nullity is the number of columns. Columns is 3. So nullity plus 1, which is the rank, is equal to 3. So nullity is 2. So the dimension of the null space is 2. Similarly, the dimension of the null space of A transpose must be equal to the number of rows minus the rank. And what is the number of rows in this matrix? You have 4 rows. Rank is 1. So 4 minus 1, 3. So 3 is the answer for dimensions of null space of A transpose. So this is what you need. Alright. In detailed computation of the bases and the spaces we have already done, but this concept of dimension sometimes confuses people. So that's why I have made this video explicitly explaining you the dimensions of the four fundamental subspaces and a simple rank nullity theorem that you can use to aid your calculations in the dimensions of the four fundamental subspaces. Thank you.